What's up guys, welcome back to another video, and in this video we're going to be going over top 3 hardest A-level computer science topics that there are for OCR. So hopefully it's helpful, and if it is, be sure to like, comment and subscribe. And yeah, let's start with the first topic, which is assembly language. So what assembly code or assembly language is it uses mnemonics. So you know, in high level programming there's we use words, so like print, def or function, etc. So in assembly code we use these mnemonics. So there's basically add. Make sure you, if you're making notes, you write this table down, the main syntax that you're going to need to know for little man computer. So add adds the content into the accumulator. Subtract, STA is a common one, which is store. Load is LDA, and the most frequent one, or the one that confuses students a lot, is DAT. So what DAT is, no pun intended, it is just a location that contains data. So we're often going to use that to basically store data. So be familiar with this, although numeric code is not very necessary. Here's an example. So if we input some random numbers, so if we input like 5 and we store that in Y, so we get 5 now, and then we input maybe 10 and we store that in Z, and whatever we input here, maybe 2, we're going to add Y onto that. So Y is 5, so 5 plus 2 is 7, and 7 minus Z. 7 minus Z, which is minus 3, so we're going to get a minus 3 over here. So what we did here is basically this got stored into Y and then Z, and whatever we input over here, that's technically like X, add Y, subtract Z. So if we plug in these numbers, we get our answer. Z, which is 10, we get 7 minus 10, which is minus 3. So that's how you can do this type of question. Now let's look at trying to actually write some assembly code. So write an assembly code program to input a number X and calculate the output 6X minus 5. So try and pause the video and have a go. And then once you're ready, click play. I highly encourage you doing this because it might come up for your 2025 A-level computer science paper. So first things first, we need to basically take the input as what we would do in a high-level program. So input, and store that into a data location somewhere. Let's call it X. And let's create an X with a DAT for data location. What we want to do is, since we can't really technically multiply here, all we're allowed to do is add and subtract. So what we can do is add X onto this 6 times, something like this, and then subtract. And be careful, don't put 5, put a new data location called 5 that has this stored, which is 5, like this, and then output. So this is one way you could do it. Another way maybe you can do is by grouping the 3's and then just saving that and then adding that 3 on, but that's one. I think this is the better way to do it. But let's move on to the next one. So this is the next question. The first 7 numbers of a Fibonacci sequence are these. The code is written for the first 5, but it contains an error. So state first 5 or state 5 outputs that this code would give. So first things first, make sure you pause the video, have a go. And now we load max, which is 5, and load A, which is 0, and output that. Then we add B onto 0, which is 1. Store that in B. I don't know why I did that, but then we store that in B, and then load B and store whatever B is in A, and we load max, which is 5, subtract 1, 4. Go back to the start, we get 4. Load A, which is now 1, so we output that. We add 1 onto 1. We add 1, or add B, which is 1, to A to get 2, and we store that in B. Then load B, which is 2, store that in A, so you get 2. You store that in A and load max, but we subtract 1 from max, so you get 3. Then we load A, so we get 2, and we output that. Then we store that in B. No, we add 2 onto that, so we get 4. Store that in B, and then we store that in A. We load max, which is 3, subtract 1, so you get 2, and then we load max, which is 2, load A, which is 4, output that. And any ideas what's going to be next? Well, we add B, so 4 onto 4, so we get 8, and then we're going to decrement max by 1. This time we're going to get 1, but that's what should have been outputted there. And clearly what's happening here is we're just replacing whatever b is into a, like nothing, we're just adding a and b each time. So if it's 2, we're getting 4, if it's 4, we're getting 8, etc. So what actually needs to happen is we need to somehow store these two and add it onto here without overriding the number. So I guess that's what the next question is. Pause the video, have a go. And we straight away see that it's very similar, but the only thing that they added is an extra data value, which is going to be temp, because we don't have a data for temp. And now instead, but here what we're going to do is load a and then output whatever that is. First time it's going to be 0, but we also want to output 1 on the second time as well. In order to do that, we have to load b. Here you see we're adding b onto a, but we don't want to do that. Instead we want to store b's value into temporary. That way we have that saved. And then what we're going to do is load a, and by loading a we get 0 and we store that in b. Add b onto a, which you get 1, and store that in b. That's already 1. And then what we want to do then is load the temporary variable and store that, whatever that temp is, into a, and then decrement as usual. But I encourage you to go through this program a few times and see if it actually, how it works and what the logic is. Now on to another A-star question. This was poorly answered when it came up, so let's decompose it and go through it. So write a program using little man computing that will allow the user to input two numbers and then output the larger of the two. This should loop continuously, so you can't just halt. The main thing is, how would you check if two numbers are, if one's larger than another? Using obviously simple addition and subtraction. Well, if I give you two numbers 3 and 6, which one's larger? If you take away the smaller one from the larger one, you get a negative. That tells you that the first answer that you gave is smaller, i.e. the second one is larger. If the first one that you gave, if this is a positive, remember branch, always branch positive, that's what we're going to use as our if condition. So if this is a positive answer, we know that x1 is larger. But if this is the case, then we know that x2 is larger. And this is what we're gonna basically apply. So that was your hint. Try and have a go if you can try and figure it out. If not, continue watching. So as per usual, we need to input, or we'll take input from the user. So inputs, and we're gonna need to store that in X, and obviously create data points or location for that. No pun intended. We're also going to take input and store it in y, x as 3 and y as 6. What we need to do is subtract y by x. Y is clearly larger, so we're going to branch if positive into maybe out y, and then create a section where it's out y, and all we do there is load y and output y. Otherwise, if this is negative, so i.e. if it's the other way around, 6 and 3, we want to basically output x. So for that we would just load x and output that. Now this would be enough if it didn't say the last part, which is should loop continuously. So to do that, a trick is just to put start over here, and then after you output it, say branch always, which is BRA start. And same here, when we output y, just say BRA starts. I know it's a bit messy, but I hope you understand the idea behind this. Next topic that most students find difficult is object-oriented programming. So what that is it's a style of program, like how we have procedural, we use procedures and pass down the inputs into other procedures. This type of paradigm is used to basically solve problems by using objects that interact with other objects. So what a class is, template to make an object. So objects have state, which is represented by variables or attributes, and they also have functionality that they have like method. Let's look at an example. So here's a class for a house. So these guys over here are the attributes and these are the method. A key point here is these guys should be private, because that's encapsulation, which we'll talk about in more detail later on. This method is a very special method, and it's given a name of new, and it's called a constructor. And as the name suggests, it's used when you create an object. So down here, if we look at this line of code, this is called instantiation, whereby we create the object using this class. So we first give it an identifier. This could be any variable name. In this case, it's my house, and we set that to the new, which is referring to the constructor, and then we call the class name, and then we pass in 3 parameters or arguments. Now, these arguments are then passed. As you see, these have to match what's given in the constructor. So every time you set a red, that's going to be given into this variable here, which is going to set the door color. So you do door color equals the variable that you passed in as a parameter in this constructor, and you do this for however many you want. And that's how you basically create an object. And once you created the object, you want to do things with it. So for example, we want to change the floors. So we can do this by doing my house dot by the method name, so change floor. And we can give it a given floors, which maybe we want to change it to, or create maybe a 2-floor house. That's how you can do it. Now, we talked about encapsulation, and what that is that these attributes must be private and can only be accessed by the public method. So for example, this change floors is a public method which is allowed to change door color. This is allowed to change floors, and change door colors is allowed to change this variable here. You can also create another method, maybe change garden, and that would take in a parameter, and you would just set that equal to, you would set garden equal to the new parameter that you passed in. Hopefully that makes sense. I've seen many questions whereby you need to create a constructor, and what you do is you pass in 3 different variables and you set this variable equal to the new variable, and you get the full mark. We'll see an example shortly, and I hope that encapsulation is clear. So that's what we're going to talk about in a more formal definition over here. So what this is attributes are private. Make sure you remember that the variables that are in the class need to be private, meaning they cannot be accessed from outside the class, and the methods are public. By attributes being private, they cannot be altered from outside the class in ways that we don't want to. For example, if we set the floor is equal to -1 future down in the program, and if it's public, meaning anyone can access it, any other function or class can access it, that could be problematic because you can set it to -1. But we know here that there's a function that we check. Well, it has to be greater than 0, because you can't have a negative floor house. So that's why encapsulation is very helpful for it. Now, the second buzzword or rule or keyword that you need to know when it comes to object-oriented programming is inheritance. So what this is like where a class inherits the methods and attributes of a parent class, as well as having its own. For example, the bungalow inherits from the house, so automatically these attributes here for door color, floors, gardens already is accessible to bungalow, as well as these methods over here. Now, what's important here is you can have your own attributes for the children or the child, and the constructor, if you notice, there's a special thing over here which is super.new. Now what that does is it refers to the parent's constructor. And every time you create a bungalow object, it first does its own constructor with given door color, given guard, given port. For example, over here when we create this, and then we basically pass in that or whatever value that we want. For example, 1 to given floors, we pass that to the parent, and then we also hard code these values in just like before. So make sure you don't forget the super.new terminology. That's to access the parent's constructor method. So by doing this now, we can, as usual, we can access the methods such as change porch, which would be my bungalow dot change porch to be false or true. And yeah, that's basically inheritance. And we can also kind of see this in a more real life scenario whereby we have a data structure class. Maybe if you've covered data structures, you might be able to understand this. So we have the attribute size is full is empty and add item remove item, and then we have queue and stack both inheriting from data structure. Now you might be wondering, why is there a remove item in both of these classes? Well, the beauty of object-oriented programming is that these children can have their own methods and you can redefine how they work. depending on the object. So that's a very important part, which is polymorphism, which is the third buzzword when it comes to object-oriented programming. So this is the ability to process objects differently depending on their class. So for example, the stack class redefines the method of remove item, what we kind of do here, because obviously you know that stack removes an item differently to a queue. Now, a key word over here is overriding. So this is when a subclass has a method of the same name and structure of the parameters as its parent class. The child class version is always used over the parent class, so it essentially overrides the parent method. So if we come back to this example class over here and we had another change floors in the bungalow method, we would use the change floors of the bungalow method instead of this over here for the child. That's basically what overriding is. And we can kind of see some of the advantages of object-oriented programming. So encapsulation. Once an object is created, knowledge of how its methods and implementation are not required in order for the programmer to use it. It's like using libraries and functions. Those are objects that you don't really need to. This way, each object is written, tested, and maintained independently, saving time, etc. And also you can reuse these classes once you set it. So maybe you have a class for a data structure and then you can just use it wherever you want. So you call a stack wherever you want to use it in your program. So these are some of the advantages that you can apply to question. And now let's do an example, which is basically going to encapsulate everything that we've learned. So there's a game and a class called treasure that is used to store treasure objects. So the design for the class and attributes and methods are shown here. So we got value, level, and we got get value, level, and the construct. So what we need to do is we need to define the class basically without writing the get methods. So this is a typical question that I've seen in loads of past papers, especially section B. So the way we're going to do this is basically make sure you know the pseudocode for it. I mean, you can do it in Python, but I'm going to use pseudocode. It's much more easy. And then private attributes. Once that's done, we're going to now use the constructor or create the constructor, which we're going to do probably procedure new that takes in a different value to that. So p value and p level, p diddy. And then we're going to basically set the original value of value equal to p value and level to equal p level and end procedure. And then we're going to, that's it. So make sure you just end class because it's again pseudocode, and that's basically 5 marks for this. Now part 2 says you have to write the get level method, and you should all know how to do this. You should all be getting full marks now. Public function, remember the difference between a function and a procedure. Function returns a value. We're going to be returning level's case, that's why it's a function. So public function get level that takes in nothing because again you don't need to set it. And then we're going to return level, the original level, and then it's a bit messy, but I hope you understand the gist of it. So that's how you can write a getter method and the constructor method and basically a whole class. Now another thing that I wanted to touch on is perhaps for part 3, I've not included it, I don't know what that is, but perhaps for part 3 we want to create a new object called treasure with these initial methods, these initial parameters. So how would you do this for maybe 2 marks? Try and pause the video, have a go, do it in your brain, and then click play. So how we would do this is basically, remember, set a variable name called my treasure or something, any random name would do, and then set that equal to new. Remember, that's the constructor, and then the class name treasure, and we're going to pass in the parameters which we initiated over here, p value, p level. So value is going to be 100 and level is going to be bronze, and that's basically you instantiating the object or creating the object. Now maybe for part 4 you want to write the setter method. So all you have to do is public procedure set maybe level. That's going to take a new level which is maybe p level, and we're going to set that, so the original value, which is not value, level, equal to the value that we set over here, end procedure. But it's not going to be as simple as this, because maybe a question says you can't set a negative level. So in that case you just put a simple if statement there, like the previous example, or etc. But the main gist of object-oriented programming is this idea of having attributes and a constructor and creating the object. These are the fundamental ideas that once you know, you can apply it to any question. But that's also a given that you're good at programming, which it should be the case if you're doing A-level computer science. So that's that. Now we're going to move on to the third topic that most students often struggle with. Typically, recursion because again the idea is quite abstract. So what recursion is, it's a function that basically calls itself. And if you have a function and it calls itself like def foo that has n, and then you just print foo n plus 1, what do you think this is gonna do? Well, if you think about it, you put 1 as n. If you call it as foo and then pass in 1, this is gonna be 1. This is just gonna keep calling itself. With first time it's gonna be 2. Well, first time it's gonna be 1, and then you put 2, 3, 4, 5, 6, etc. And it's not gonna stop, and it's not gonna be printing out any. Hence why it needs to have these three main things in a recursive. So a base case, which is a stopping condition. So in this case, if we set if n is equal to let's say 100, then return 1 or something, then when it hits 100 it's going to return 1, and then all of the rest are going to unwind, which we'll come to next. So for input values other than the stopping condition, so other than 100, the other conditions, other values, it must call itself, which it is, and the stopping condition must be reached after a finite number of calls, meaning it can't go on infinite, whatever. Actually, before we look at an example, it's important to note that whenever a function calls itself, or it's put onto a stack, which is the data structure. So if we draw a stack, when we call foo, we put on foo 1 onto the stack, and then foo 2 goes onto the stack, because again we don't know the value of these numbers, so we just keep on putting it into the stack until, well, the base case is met. Once that's met, then we're gonna unwind, pop it off the stack, the values. But if there's no base case, this stack is not unlimited. There's a limit of around 999 or 9. There's a limit base, and once you hit that limit, you're gonna get an error that says stack overflow. If you're doing your A-level project, you must have met this guy somewhere. So that's stack overflow, and that's why that happens. So when a function calls itself, it gets put onto the stack. But there's more to it than that, because the parameters and all the the memory location, all of that is put onto like a stack frame, which is an individual item with many other elements to it, which we're not going to go in because I don't think it's important for learning or understanding. Actually, it is important, but not for this video. So maybe if you want me to go over recursion in more detail, then I'll definitely do a 1-hour lecture on recursion. So this is an example of what we just kind of looked at. So on the left we have a procedure counting that takes in parameter n. So if we print in 1, put 1, we're going to print 1, and then it's going to call counting at 1 plus 1, which is 2, and then you put a 2 there, you're going to get 2, then you're going to get 3, and so on until the stack overflows at, so that's very bad example of recursion, because there's no base case, there's no stopping condition. So now let's look at the thing on the right, or the function on the right, and now here if we call counting with 1, it's first going to check if n is equal to 100, then print done. Well, that's not the case, so we're going to print n, which is 1. Then we're going to call counting at 2, which is going to go there, and 2 is going to be printed. And then it's going to call 3, etc. until n is 100. So when that's 99, we're going to get 99 plus 1, which is 100, and then we're going to print done. And then what happens to the stack? Well, what happens to the stack is we then get rid of it, because we've found the value, which is at 100 is going to be done. So at 99 it knows to do nothing, because we're not doing special. But how would we reverse this action? So instead of getting 1 to 99, how would we get from 99 to count down to 1? Think about it for a second, and this is how you would. So basically we would have to switch these two around, and if we do that, we're then going to do the first time we'll get 1. Let me do this in a different color. The first time we're going to get 1, but it's not going to print, because it's going to call 2 and so on until counting 100, which then we know that that's true, and that's going to print done. So that's going to be done first, and then when it goes to 99, then we know the value that's done, which gets popped off, and then we print n, which is 99 and 98, etc. So that's the way recursion kind of works, which is by every time it calls itself, it's put onto a stack, which then we can think about the disadvantages. The disadvantages of this would be that every time you create this recursive call, you're creating a new stack item and putting it into the stack, which is taking up into the memory, which we'll come on to. Now, this is a question and it takes in two parameters, and if they're the same, we're going to return 1, and if one's less than the other one, then we're going to calculate num1 with num2 1, and otherwise we're going to calculate num2 with the others subtracted. So identify the lines where recursion, obviously 5 and 7, and then we're asked to trace it. The way that we can basically trace this is, first we're going to calculate 4 and 10, and then we're going to check if num1 is equal to num2, which is false, and we're going to do the else, this condition over here, because 4 is less than 10, which is true. Then we're going to return calculate num1, which is 4, and 10 minus 4, which is 6, and that's our recursive call. Now we're going to do the same thing for that. So if 6 is true, we're going to call calculate 4 and 2, and then here, so then we get if 4 is equal to 2, which is obviously false, and then we do else if. Now we don't do the first condition, but we do the second one because 4 is not less than 2. So you're going to do else if 4 is less than 2, which is false in this case, else return 2, calculate 2, and num1 minus num2, which is 2, and they're the same. So you see that in this call, we're going to get if 2 is equal to 2, we're going to get true, and therefore we're going to return num1, which is 2. Now that can be now popped off. So if we look at a stack, what happened is we put calculate 4 and 10 into the stack, then that called, I don't know what that is, so it called calculate 4 and 6, that called calculate 4 2, calculate 2 and 2, and it finally knew what this value is, so it got popped off, so you get 2. Then it's going to say, well, what's calculate 4 and 2? Well, that's also 2, so we're going to return that over here when we had this thing over here, return 2, then this return state is going to get return 2, and this return state is going to get return 2 as well. And yeah, so all of these guys are going to return 2, and that's what is going to get returned. So I hope that this makes sense. I know this is so abstract and probably hard to understand, but I hope that when this type of question comes up, you're able to follow through the trace table and also have a mental representation of what's going on the stack. That's the main concept behind recursion. Here's something that you can maybe write down if you're making note. The advantages of recursion is some problems are easy to think of recursively. For example, Fibonacci sequence and factorial. And remember that factorial uses a brilliant example of recursion, because let's say we want to do 5 factorial. You know that from probably maths that this is equal to 5 times 4. But what you don't know, or the way that we use it recursively, is 5 factorial is the same as 5 times 4 factorial. So if we think of a stack that will call 4 factorial, 4 factorial will call, well, that's just 4 times 3 factorial, and then 3 factorial will call 2 factorial, and then 5 times 4 times 2, and that's just 1 factorial. And we know that 1 factorial is 1. So once that gets popped off, that's just 1 multiplied by 2 factorial, which is just 2 times 1 factorial. 1 factorial is 1, 2 times 1, 2 times 4, 3 times 4, 5, which is, if you did get it this far, let me know in the comment section down below what this number is. So it tells me that you actually watched the video. But then we say that recursive solutions can be more elegant and easy to follow than their iterative counterparts, because if you think about Fibonacci, or if you think about the factorial, how on earth would you even do this iterative? You'd probably need some loop, obviously, but it's not as intuitive or easy as a recursive problem. However, disadvantages, as what I mentioned before, is it requires more memory, because it needs to maintain the stack, and if that runs out, it'll crash. And the overheads of maintaining the stack means a recursive solution can perform more slowly because it's reliant on a stack. So that's basically recursion in a nutshell. Well, little man computing, object-oriented programming, and recursive in a nutshell. I don't know how long this video is going to be. That's pretty much it. And a runner-up topic that could come in 4th place would be databases, but I've already created a video on databases. You can get the link on the top right or top whatever. It should pop up. And yeah, if you found this useful, be sure to like, comment and subscribe, and I'll see you in the next one. Good luck for your exam.